This is part 3 of my 2017 HSC, Engineering Studies HSC exam answers. And if we're now on to the short answer questions, or the standard answer questions, not multiple choice. Okay, so question 21, part A. Using examples, explain why gears are used in the design of vehicles. Okay, what you got? Okay, so I just had a great answer, which is that, aside from the obvious that you can't go in reverse without a gearbox, that cars, the engines can't provide an even torque. So that what they need to do in order to go at slower speeds is we need first gear, but then it's no longer efficient at higher speeds. So we have gears 2 to 5. So that's a simple answer. If you say it's more efficient to have a gearbox because we can provide greater efficiency at higher speeds while providing the necessary torque to move a car from a stationary position and to change directions, that's a pretty good answer. Let's have a look at what the book said. They say change direction, convert... for instance, sport cars control fast, can't pull heavy loads. It's not a bad answer. I'll let you guys read that at your leisure. But if you said that it's more efficient, that's a pretty good answer. The fact that they say using examples is important, though. So give an example of we go in first gear to start the car, so that to help us move from a stationary position. We use fifth gear at high speed. That would be you using an example. The sports car thing, though, is a really clear example. Make it easy for the markers. Okay, so then gears are typically manufactured using ferrous alloys. We can sandcast and we can use powder metallurgy. Compare these two properties. Now, we've talked a fair bit about gears made out of powder metallurgy. This is sintered metals. And what's the example I always use? Happy Meal toys, right? Happy Meal toys are under pretty low strength stresses. Yeah, that they're not having to pull heavy loads. They're never going to fail because they're pulling too heavy a load, so that we can use something that we need small, accurate parts, right? Whereas on the other hand, when we're dealing with cars, we've got large loads, and we need things that are tough and things that aren't going to fall apart. There are other advantages of using sintered metals. Those sintered metals are typically cheap for the amount of accuracy that they give you. They don't need to be machined. They can be lubricated very easily because they're porous, so we can have self-lubricating equipment. But that's enough, I think, for 4 answers. But let's see what they say before I go on and say too much. Okay, sandcasting. Porous surface, yeah, okay. Poor dimensional stability. It's not as accurate, it needs to be machined. So we can make things that are impossible to make otherwise. Near shape, so it means basically we don't need any finishing. Possible to make, they can be porous, they have higher dimension stability. Yep, okay, so I'm happy with all of those answers. Is that an example of the answers? No, okay. So, okay. After manufacturing, the gears can be case hardened. How do we case harden? And what is the structured property relationship of this application? Very wordy question, but describe means we need to say key features and properties. So, here's what my attempt would be. I would say that after we case harden by heating with flame hardening or electrical induction, and then rapid cooling or brackets quenching. This provides hardness, which means that the gear won't wear. But it does. But the advantage of case hardening, we don't need to say this, but the advantage of case hardening is that if we harden the whole thing, it won't be tough enough and it will shatter. Yes. Okay, let me just quickly look at this if you can hold that thought. Okay, so what it says here, carbon-rich environment or nitrogen, high temperature. Yep, that's true. When quenched, martensite is formed. This becomes harder and wear resistant. The gear can be used with other. Okay, so it improves. Okay, so what's interesting is that, so they talk about the carbon-rich atmosphere. So, to say specifically case hardening, yeah, okay. So case hardening is, so carburizing, I just moved into the mic, sorry about that. Case hardening is, carburizing is when we when we talk about hardening techniques, there's a variety of different hardening techniques, and there's a bit of overlap in terms of terms. I would say case hardening is typically through induction or flame hardening, but we also have age hardening, which is from things like carburizing or nitriding. Carburizing is where we squash in carbon molecules. Nitriding is where we squash in nitrogen molecules. Those foreign molecules disrupt the lattice, making the thing harder. I think that my answer would still have been sufficient without... I was using the example of flame induction hardening. Maybe I'd get pinged on it, but I wasn't a marker on this test, so I don't know, and I certainly didn't mark that question. Okay, I'm going to pause for a second. Okay, oh god, I hated this question when I saw it. A gear train. So, what we have to think about is the ratio, the N rev, right? So how many times is this wheel turning compared to the next wheel that's turning? Yeah, so every time this turns, if this turns, it turns 9 gears, how much will this one have turned? Okay, so this one is turning faster than that one is turning, yeah? So, okay, I was going to get the calculator, but instead I'm just going to use the answer sheet. So we can ignore this intermediate gear. Effectively, we just look at the start and finish, the driver and the driven gear. So what we need to talk about is what is the efficiency we need. Well, so they're talking about 1.6 at 80% efficiency. So that means that if we think about efficiency, always makes things worse. If something's 80% efficient, that means it's less good than 100% efficiency. If I told you that 80% of your pay packet was going to be $1.60, what was your full, let's say 80% of your hourly wage was $1.60, what was your full hourly wage? $2, right? So we need to have a ratio of 2 to 1. So if the ratio is 2 to 1, we need to go from our N rev of teeth to teeth, so we need twice as many teeth here. If there's 9 teeth here, we need 18 teeth there. Let's have a look. So that's basically what they've done. Now, it's been pointed out, because I looked at this sheet while I was looking for the calculator, that that's an N. I think what they want is eta, but they were too lazy to get the Greek letter. So I'm not going to throw stones, because I live in a glass house. Before I go on, I'll just reiterate from a question from students that all we really care about is inputs and outputs. So even if there was 1,000 gears, we can just go to inputs, outputs. Okay, so we have a bike. What's one advantage of carbon fiber over steel bike frames? Oh, it says advantages. It's 3, it's outlined. So I would suggest you probably want to have 3 different things. Okay, but you put them into sentence form would be good. Okay, so what have we got? Better strength to weight ratio. Okay, which means that we can have a bike that's as strong with lower weight. Yeah, lower weight means it's easier to carry around, and it's also advantageous, faster speed in racing. Why else is it important? Okay, so yeah, the manufacturing. What we could talk about is just manufacturing process, a different manufacturing process. That's not necessarily advantage or disadvantage, but it means that we can have things like patterns, shapes, so we can produce. We have different things we can produce. The advantage is that carbon fiber can be made into a variety of shapes, and yeah, it has a different aesthetic. Now, also, what about durability? What does steel do? Steel. So okay, you said steel's pretty. Yeah, corrosion. Steel rusts. Carbon fiber doesn't rust. Yeah, so it means you don't have to worry about that. Now, in some situations that doesn't matter as much because the life cycle of the bike is not such that rust is an issue. But for most consumers, that is a problem. Okay, explain why carbon fiber is how the bike is manufactured. Okay, so there's hand layup, vacuum layup, and there's the pre-preg. Let's see what answer they went with. I'm going to say that vacuum layout sounds good. Okay, so here we go. It's placed in a vacuum. We're going to get to that. Just to quickly check, what did they say here? They said carbon fiber can be in intricate shapes. It can be produced in a range of colors. There you go. So one of the students said that. Carbon fiber is corrosion resistant and rigid. Yeah, so we got all 3 of those points. I didn't say colored, but we did talk about shape. Okay, bicycle frames. Okay, this is a long answer, right? You're not going to write that many words in here. what you're going to say is you're going to say that the carbon fiber is put in a bag with a fixing or an additive material. It is then put in a sealed bag and it's put in autoclave where at a vacuum and high temperatures it is shaped into position. That's probably what I would say. Now it says explain how. So it means you want to say because or this results in something like that. Something you've got cause and effect. So I'd say this results in a change of properties of the shape. It molds to the shape. The reason we use vacuum separately, me now no longer answering the question. The reason we use vacuum rather than hand layout is because of efficiency. I mean, or basically anything that is mass produced, we're going to be using vacuum layout. It means it's put in the bag before it's vacuumed. Yeah. Okay. So this is the pre-preg. This is the pre-manufactured sheets that are put into a bag before they go into the.
So what's the additive material?
I don't think they've mentioned additive material here. They do mention resin. There you go. Yeah, that's a term. Probably better term to use. Resin. Yeah, and activated by a catalyst. So, okay, a bike rider is going down a hill. The combined weight is 100 kilos. Calculate the speed of the rider at point B. Assume no resistance and 100% efficiency. Okay, so what we need to do is, what formulas are we going to use here? Excellent. Potential energy and kinetic energy. Now, potential energy, you always want, I think, why do we even need that as a formula, right? It should just be apparent, but it's mass times gravity times height. Yeah, so it's basically the definition of power is how far you move something. The force times distance. So the force in this case is weight, and weight is measured in a vertical distance from the center of the Earth. This guy has moved 20 meters relative to the reference point B from the center of the Earth. So he has a mass of 100 times gravity times, we're going to call that 10. So that's going to be 1,000 times 20. That's 20,000. Now that we know the 20,000 part, we know how much energy he has before he starts. We now need to find out what the kinetic energy formula is. What's the kinetic energy formula? Half mv squared. I could go to the, let's do it. Go to the formula sheet, and where is it? We're going to use, right, it's the first one. Well, not the first one, but you get the idea. Half mv squared, right? So we need an answer that's going to equal 20,000. Well, first of all, we've got the half. So if we get rid of the half, okay. We're going to use the sheet. I always forget we've got the answer sheet to help me rather than me having to write stuff up on the board. Okay. So they've just rearranged the formula, right? So they've taken half mv squared, they've turned it into capital V, which I hate, but they've turned it into V equals the square root of 2gh. So if we sub in the values, right, we get the square root of 20,000. We're going to get 20 meters per second. Okay. So it's 20,000 should have been 400. Whoops, my bad. Yeah, 400. Square root of 400 is 20 meters per second. Okay. I don't care. Okay. So, this is an interesting question. It goes over a bump. There's a 3 kilonewton force applied axially on this member. It's an axial force. There's two kinds of axial forces. What are they? Tension and compression. Exactly right. What's this one in? Compression. Excellent. Okay, compression in the real world, we do have to worry about buckling. That is a disadvantage of compression compared to tension. Right? The advantage of compression is we don't have to worry about bolt holes, because the bolt fills the hole and the bolt is usually as strong as the material they're replacing. Though I say that because there have been HSC questions that have talked about that. Okay. Now, they're asking us to calculate the compressive stress acting on the pillar. Now, how do we do that? Well, what we need to do, what's the formula for stress? Force over area, the second most important thing you need to learn in the subject. Okay, so force over area. Now, the area, we're going to calculate the area by doing 32 squared times pi divided by 4 minus 28 squared times pi divided by 4. Right, let's have a look over here. They may have, it's a hollow tube. And now I was thinking they might have used pi r squared, like some sort of lazy mathematician, but engineers, we use pi d squared on 4. Okay, which is exactly what they've done. They've done pi over 4, 32